Hi, I know that you are here to find out how NSA helped me solve a challenge, so let's not just keep you waiting. The challenge was one of the challenges during qualification round for the bi.zone CTF 2019. It was called Mega Drive Crack Me, and yeah, so let's just find out how NSA helped me solve it. So in these challenges, I guess we got some kind of description from the challenge page, but yeah, it's not available anymore. But anyway, we can find out a little bit more about the challenge, although the name suggests a little bit already. But we can run the file command on the bin file, and we get that it is Sega Mega Drive Genesis ROM image, and we have some kind of additional information here. May be helpful, we don't know. So the good thing that we could do in such challenges is to actually run it. And unless you have a Sega Mega Drive and the ability to write those ROMs to some kind of hardware, we will use an emulator. And the one I'm using is this Gens Plus, or Gens Plus, depending how you pronounce the G. And let's just load the file. Okay, and we can see some logo, CTF Zone, welcome to CTF Zone. Use D-pad to enter a key, press A to check it. Okay, and we can use arrow keys to move around through the digits or through the inputs, and we can actually change each value to desired character. And it's good actually to run it so we get a little bit of knowledge about the binary, so we can see how many characters we need to enter, and also what's the available characters that we can use. So let's see, we have digits, and then it looks like we have some special characters and capital letters, and that's all. So that's all we can use, and of course, as it says, we can use A to check it, and it says incorrect key, please try later. And we can do again, okay, and again, and again, and again. And yeah, so how we can find the correct flag and how NSA can help us. And of course, by NSA, I mean Ghidra. But the Ghidra was developed and released by NSA. So yeah, NSA helped us to solve this challenge. So let's just import the file to the tool. And the first problem is that Ghidra doesn't know what kind of language CPU this is. It only identifies as raw binary. So we can use wiki to actually find this information, and here we can see that CPU for the Sega Genesis was Motorola 6880 and Zilog Z80. Okay, so that at least one information we can use here. So let's just filter by this CPU, and I guess we will just use the default version or default variant. And let's just press OK. And Ghidra will load this file, and now we can release the dragon. Okay, and the Ghidra asks us if the file was not analyzed, whether we would like to analyze, and actually in this case we'll say no, because it will screw up the addresses by its analysis, and we don't want to do that. What we want instead, actually use a great script developed by ZZNob on his GitHub. In Ghidra scripts there's two scripts for the Sega Genesis. One is Genesis checksum, and the other one is Genesis vector table. And if we look at them in Ghidra, we can open them in Script Manager, and I already have them filtered. So the first one is actually fix some Sega Genesis ROM checksum, and the other one is given a raw binary, construct the vector table and ROM header, and kick off disassembly. And this is what we want to run. So let's just run the script and wait a little bit. It's not that long. Yeah, okay, it actually says it's finished, and it actually initialized some values and add some labels for us. So we actually can see, okay, it's initial stack, program start, and I guess this is really interesting to us, and some other values which are not that interested right now. So let's just go to this program start, and we already see some code, and the decompilation actually works. But then how we can find out the actual code where the flag is being checked. So in this case, actually we can try looking at the strings. So Ghidra identifies all the strings that it can find in the binary and can list them for us in this defined strings tab. And we can see, okay, welcome to CTF zone, use D-pad to enter key. So we can see all the values that we saw on the screen. And also we can see this incorrect key. Please try again. So actually we already have a identified string that it's printed when the flag is incorrect and also key is correct. So let's just go there. And we can see the string is defined here and it's being used only in one place in this function at this address. So we can jump also here and we can use again the decompile tab to actually see the code, and we can see a lot of undefined, a lot of local variables. But if we scroll down, we can actually see something is happening here. So there's some variables being set. This looks like an ASCII characters. We can actually try and convert them to ASCII characters, and we will see what the values are. So it's I for capital T and J. Okay, so we already have some characters, and we can see even more characters being assigned here also. So we could convert all of them to ASCII because it's easier to read ASCII. But then later we can see bunch of ifs, and if you see ifs, you can assume that something is being checked and it might be a flag. And actually if you would identify the code and identify the local variables, we would see that this is actually the variable that contains the flag, and we could see in the application that it expects 16 characters, so 10 hexadecimal, and it stores in this variable. So we could actually rename this as a flag. So I press L as a default for the rename, and we type flag. Okay, so it's a bit easier now. So we can see, okay, there's some ifs on the flags, but we have those nasty underscore with numbers, and we can change that by changing the variable type. Because right now, if we can see, it's undefined 4, so it's like 4 characters, and we can try to change it to 16 characters because it's 16 characters that we are entering in the program. So now it makes a little bit clearer. So we can see, okay, flag 0 we multiply by value of capital O, and then we add flag 1 and multiply by parentheses, and then flag 2 by 04, and so on and so on. And we expect this to be equal to -9. So I guess it's signed value, and then some additional checks, and this has to be equal to 2, and then we set some variable. If it matches, we set some variable to some other expression, and otherwise we set to 68 hexadecimal. And then we have more checks, like, so here it was 0, 1st, 2nd, and 3rd characters. Here it's 5th, 4th, 6th, and 7th character being checked in different combination. Here it's 9th, 8th, 10th, and 11th. Well, +1 because those are indexes. And again, different combination, different values. Well, some values are the same. So we see O and O here, 4 and 4. And well, maybe it's even the same values. And then 12, 13, 14, and 15 characters. And then we see the checking key string being used. Something is done. And okay, if the value is 69, the IVAR5 is 69, then the key is correct. Otherwise, if we scroll down, I guess it will be incorrect key. Please try again. So we need to make sure that this IVAR5 is equal to 69. And when it will be equal to 69, well, here we can see it's being assigned to 68. So the only way we get the 69 is if this expression returns 69, and it will return 69. This is 69, so and something is being added to this, so we need to make sure that this returns us 0. So then 0 plus 69 will give us 69, and then everything will be okay. So what we can do, or actually what we have to do, we don't have to, but it's nice to write a Python script that will actually solve all those checks. And it's quite easy to do because we only check 4 characters at a time. So we can even brute force it. It's not that many characters we check each time, so 4 is manageable. If you would have to check 16 in every turn, that would be quite difficult to do, or maybe even impossible. But since it's 4 at a time and we do it 4 times, then we can do it. So I have write such a script during the competition. So this is how it looks. So we have our alphabet, so it's only digits, those special characters and capital letters. Then the flag is actually 20 characters, but at the 4 indexes we have zeros being put there, but it doesn't matter for this script. We have a rounding function that actually round the value to 1 byte, because we saw those being compared by byte. So here's the char, but it's like 8 bits value that we need to round to, because Python, well, doesn't care about the size of int. It will grow indefinitely, so we need to cut to 1 byte in our script. And then we have those 4 checks, well, rewritten in Python. Well, maybe not perfectly, not beautifully, and I can see I have some semicolons from other languages here. But anyway, from iter_tools, we create a product from alphabet values, and we want 4 values, and then we assign them to X, Y, Z, and W. We assign to flag, and then we have the same checks as in the program. Okay. We also have this additional equation calculated, but finally I didn't use it. Well, it will create a bit of additional values, but we'll solve that in a moment. Then we have from 4 to 7 characters, from 8 to 11, and from 12 to 15 characters. So I just rewritten those expressions to Python, and well, yeah, that's basically it. We need to run it and see if we will get anything from our script. So let's just use it. Okay, and it tries to find the matching values, and it found 2, and this is the problem I was referring to. We will solve it in a moment. From 4 to 7 it's those only, from 8 to 11 those, from 12 to 15 those characters. And the problem with here is that one of those will also match to this expression f, that it will return 60. Well, this has to return 0, but I didn't check it in the end because I only got 2 values, so it's just easy to check them manually. So let's just try that. Okay, we have our characters, we have our application. So let's try the first one. So we have U, and the second one is also U. It's not very convenient to type those characters here because it's very difficult to navigate and to correctly type a value. Now we have a colon. Okay, where's the colon? I can't find the colon. Probably because I'm pressing too quickly. Okay, and then then we have an X. So we can go all the way to X. Then we have a question mark. Okay, question mark. Then L, C, D, G. That's really not very convenient to type those, but anyway, okay, we have already half. Then again, semicolon. Again, I can't find it. It's hiding somewhere. Okay, then we have B, A, B, and O, p and a bracket, and then the last one, too far away, okay, equal, and v, you can go all the way up, almost, okay, and a semicolon, okay, and then we press A, and the key is incorrect because actually it's the second one, and I already knew that, but I just wanted to show you that, okay, sometimes it's faster to even have a bit more results and check them manually than to code something. Well, it wasn't that hard to code it here, but anyway, sometimes it might be. So if we don't get too many additional results, we can actually check them manually. Key is correct. Oh my god, it's full of flags, lol. So this is how you could solve this challenge, and using NSA tools, Ghidra. Yeah, so I guess that's all. I hope you like it, and if so, click like and subscribe, and yeah, see you next time on the next challenge. Bye.